Okay, the subject of today's online live class is MIDI, M-I-D-I. It's also the subject of quiz number 3, which several, about 12 of you have already taken, at least the first time. And you may have some questions, so hopefully this video will be helpful. Also, I apologize that last week's video, which was kind of a walkthrough of how to do the the looping project, never posted on YouTube for some reason. Of course, the directions were clear enough that nobody had any trouble doing it, but it just, for people who are visual learners, gave another opportunity for people to do that. We are going to talk about what MIDI is, and and on the looping project you got a little experience because some of the files you may have dropped into your looping project are MIDI files. So what is MIDI? I have Nick here in the room with me, and we're going to talk a little bit about this and also address any questions that he might have, and they're probably going to be questions that several of you will have because Nick has already taken the test once and had some questions. He mentioned to me that this test is a little more specific than previous tests. So MIDI stands for Musical Instrument Digital Interface. And Musical Instrument Digital Interface, as you'll read in your book, is a protocol. Kind of think of a protocol as a computer language, but it's not really a language. It's just a way that computers interact with one another. And in this case, it's computers and also other devices. So the MIDI protocol was created so that musical instruments, tone modules, controllers, synthesizers, that musical instruments could interact with the computer. Now, when this happened, this was in the what does it say in your book?
Early 1960s?
1960s or 1970s? Oh, let me grab my text here. Should have it with me.
Or 1980s?
Yeah, so they started looking at this in the late 1970s, and by the early 1980s, they decided on a consistent protocol. See, there were different computer companies and there were different music hardware companies, and they were all looking for a unified way for computers to interact with the hardware. And so they created an organization, and out of the organization came this MIDI specification, sometimes known as the MIDI spec, and it was Musical Instrument Digital Interface. The idea is that if I were to create a musical project on one computer, I could take it and I could move the hardware and use a different computer and just save the file, and I could reproduce the same project on another computer. Now, you have to understand that when I say creating music on the computer, that in 1981 it was very different than it is today because they weren't creating audio. That is to say, I couldn't record a cymbal crash, or I couldn't record Itzhak Perlman playing the violin. Computers simply could not deal with what you guys now know as digital audio and the 44,100 samples per second digitized and then coded at 64 bits of information. They simply could not deal with that. But what computers could do, they had determined through electronics how to produce sounds. And they put these sound cards in a computer, and so you could tell the computer, make a sound, and the computer would basically, it has its onboard synthesizer, and it would generate the sound. Okay? So what MIDI is a way to create messages that would tell the computer to make the sound. So while I could say to the computer, make a flute sound on the pitch C and make it last for 1 quarter note, and the computer could do that. If I moved that information to another computer, it could also do that, but because it had a different synthesizer, the flute might sound a little different. So even though you would get the general idea, each computer, their instruments sounded a little different, but the language was the same. So if it played as a flute sound on one computer, it played as a flute sound on another computer, played as a flute sound on another computer, and it would all play the same note, and it would play at the same time. So those messages, MIDI messages, were important for this protocol to work. And so in your book, you're going to learn about different kinds of MIDI messages. And there's note messages, and there are control messages. There's a lot of elements of music, right? And so what they try to do is create different streams of messages for all of those kinds of control. So what are some examples? So pitch, how high or low the note is, right? Note duration or length, okay? And the way they do that is by sending a code that says on and a code that says off, okay? So we have pitch, we have duration, we have the instrument sound, okay? We have the dynamic level, whether it's loud or it's soft, or louder or softer than other sounds. And so you have all kinds of things. I could put some of these things down. Pitch. The sound of the instrument, or I'm going to remind me to come back to this. Okay, the sound of the instrument. We learned to call that tone color in our first quiz. Okay, so the sound of the instrument, the timbre or the tone color. Time, duration. So time when something happens. Duration, how long it happens for. Pitch, sound, instrument, time. We have some dynamics, which is loud and soft. In time, we could create fast and slow. So these are all musical elements. And what we did is we just said, do this at this time with this sound for this long and sound this way. And those messages, as it turns out, take very little space for a computer to do. A computer can send those messages very easily, can create that information and store it in a file, take up very little room, use very little processing. And then when it gets to the computer, it takes and it sends that message to that computer synthesizer, and the computer synthesizer or sound card generates the pitch. There we go. So in a MIDI message, I can make things sound like various instruments. What I can't do is I cannot replicate any recording. So I don't have anybody's voice because there's no synthesizer that can produce Michael Jackson's voice or anybody's voice for that matter. I can produce a voice sound or an ooh or an ah sound, but not anything that really resembles a person singing. And I can produce elements that really sound a lot like the music, but to our ears these days they sound electronic or computerized, right? Because they're coming out of the computer synthesizer. Okay, so this is kind of the concept behind MIDI, and I want to talk for a little bit about how MIDI is connected, and to talk about how these messages are transported. So we have our computer here. I'm going to draw a laptop because I can easily draw a laptop. There we go. There's a laptop computer, and I've got a computer here, and let's say I have an instrument. I'm going to create a keyboard instrument here, okay? And I want to take this keyboard instrument and I want to connect it to the computer, okay? So I also, in this case, the keyboard is going to send the messages and the computer is going to receive the messages and interpret them. There's something else I can do. I can use a piece of hardware called a module. By the way, I'm going to say hi to DJ who's just joined us. Hey DJ, welcome. We're just going through our discussion of MIDI. After the fact, you can go back and watch the recording to catch the beginning.
All right, thank you.
So I have a sound module. Okay, so it's hardware that produces sound. And the module can receive messages just the same way the computer is. So I could take the keyboard, which is sending messages, and I could plug it into the module, and it could make sound. Or I can even build MIDI messages in the computer and send them to the module, and the module can make sound. Or I could create messages from the keyboard, go to the computer, go out to the module, and in this way, we're taking the messages and we're producing the sound with them, okay? Now, in this instance, I call this keyboard a keyboard controller. A controller can look like a keyboard, or it can look like a drum pad, right? With a bunch of little pads on it like this. I touch a pad, it sends a message, and it makes a sound. Or it can look like various other things. In this case, where we call these controllers do not have, and it says this on page 132 if you're using the first edition of the book, a controller does not have any sound in and of itself. So a controller is exactly like your typing keyboard on your computer. That typing keyboard, all it's doing is sending messages. Okay? Don't get a MIDI controller confused with a synthesizer. Okay? A synthesizer is a keyboard controller with a module built in, or in other words, here's our module. Or in other words, it has its own onboard sound card, right? So a synthesizer, and see, this is where in 1981 synthesizers and computers all started coming together, because I could build a keyboard and I could send messages and put an onboard computer brain in it, and I had a synthesizer, right? There you go, I had a synthesizer. Well, they started to say, well, what if we put the musical brain inside the computer, and we can just communicate from the keyboard to the computer? So there you go. So these are important terms, aren't they, Nick? Mm-hmm. For the quiz. So controller doesn't have any sound by itself. Module creates just sound. The computer can be used to send sounds from the keyboard to the module, or you can go directly from the keyboard to the module, or from the module to the computer. And if I have a keyboard that is a MIDI controller that has an onboard module, we call that a synthesizer. Okay. In the Music Tech Lab over at HC 317, you will see that those are MIDI controllers. They're not synthesizers. And one of the easy ways you can tell is if you look on the back and there's nowhere to plug up speakers, it means it doesn't generate any sound on its own, right? Mm-hmm. And so that's how you can tell the difference between a controller. Also, controllers are much less expensive. You can get a nice controller for $100 or $200, and a nice synthesizer might cost you $1,000 or $2,000. Okay, because it's all about that computer brain inside the synthesizer. Okay, so this is important to understand for the quiz. Any questions about that, DJ?
No, sir.
All right. Nick's shaking. He said he doesn't have any questions either. Good. So let's talk about then how they communicate. Oh, by the way, I forgot to mention this. There are 3 ports. The plugs for MIDI look different than other kinds of plugs. And I want to point this out. There's a nice graphic on page 135 if you're using the first edition of the text. Page 135. These plugs look kind of like this, and we have in, we have out, and we have THRU through. Okay, so you have in, MIDI out, and MIDI through, and they do exactly what they say, which is that if I have a keyboard controller and I take a MIDI cable and I plug it in to the out of the controller and I plug it into the in of the computer, then that's the way the sound is going, or that's the way the messages are going. I can also use the through, and by putting a bunch of, so I can go out of the out of one MIDI controller into the in of another MIDI controller, and I can go from the out of one MIDI controller into the through, and then into the through of another MIDI controller, into the through of another MIDI controller, and then eventually out of the out into the in of a computer. And in this way, I can put 5 or 6 or 8 or 12 MIDI controllers all together. We call that daisy chaining when we put those together like that. Daisy chaining. Also important for the quiz, isn't it? Mm-hmm. Daisy chaining.
And all three look the same, correct?
They are. They're exactly the same plug-in. So on the back of the device, it'll say in, out, or through.
Okay.
Yep. They look exactly the same. Okay, now today, We usually, well, first of all, you've never seen this plug on the back of a computer, have you? Never seen it. Now, if you have a MIDI keyboard and you look at it, you'll see that plug, although we almost never use it. It goes unused because the way today, see, it used to be you had to buy a little box that had these 3 plugs on it, and then you would plug it into a serial port on your computer, and that would allow you to interact. Today, we use something called a USB cable. So MIDI showing up very well. USB cable. Okay, so the MIDI spec is a serial communication. Okay, it's a serial port. What that means is it takes all of the pieces of information and it lines them up like cars on a one-lane road. Okay, and so a serial port works by taking all of the pieces of information and lining them up on one lane. And for a while there, in the 80s and the 90s, computers had what they called a parallel port. Parallel port was you actually had a lane for each bit. So let's say they were running 8-bit computers. You actually had 8 wires in the cable. You had this thick cable, and you had an 8-pin connector. And then they went to 16-bit, and you had 16 wires, and you had a 16-bit connector. And what they were doing is they were transferring the information 1 bit at a time in its own lane. That seemed like a good idea at the time, but can you imagine a parallel connector for a 64-bit computer? It would be insane. Well, what they discovered is that because things are traveling, this information is traveling at the speed of light, that we can take all of the information and line it up in order and run it down a single lane, and it doesn't slow down. And in fact, the communication for USB has gotten so fast that the serial port has become the universal use, hence the term the universal serial bus. Okay, so
Is that really the abbreviation, Universal Serial Bus?
It is serial, yeah. So it's a serial communication. Universal Serial Bus is what USB stands for. And because MIDI is a serial message, it easily works across a USB cable. So we use USB cables now instead of MIDI cables. And every MIDI controller that you buy will have a USB output. Okay. So let's go back to these messages for just a second. That's how they communicate. And so what are they communicating? Well, they're communicating information using a series of numbers, just like computers know how to do. And we know from last quiz that binary is really important. And so the messages are in binary. And to give you an example, if the information I want to talk about is pitch, I can say, okay, my category is pitch, and I want pitch number 64. Okay, 64 is, I'm going to look in my book, and you want to have this handy when you take the quiz, because I'm going to ask you about some MIDI messages. I think I have it in here. On one of the pages in the book, it has the musical alphabet, I think, by MIDI message number. Well, let's say 80. 80 is a C, so 80 is a C2. That just means the second octave from the bottom of the piano. That would be 80. So I give it a number, right? And it turns out that I have values between 0 and 127, okay? Well, how many keys are there on a piano? How many keys are on a piano? You know? There are 88 keys on a piano, okay? 88 keys on a piano. And if I have values from 0 to 127, I can assign those 88 keys in there without any problem, okay? The reason that we have, by the way, so this number from 0 to 127 is the same range we use for which instrument it is, for how much time it is, for how much duration, for what the dynamics are. So for example, loud is 127 and soft, or no sound at all, is 0, okay? So if I want something to be louder, I can make it 80, and if I want to be louder than that, I can send the message, well, let's make it be 90, okay? So by changing these numbers, I change the information here. But all the numbers are in ranges from 1 to 27, 0 to 127. The reason that's important is because I want you to understand that this has to be based on a bit technology. So let's go back to our binary for just a second. So these are the ones, yes? Twos, fours, eights, 16, 32,
64.
and 64. So if I put ones in all of these placeholders in binary digits, what's the number that I get?
255 or 256?
Nope. Hold on. I only went up to 64.
Oh.
I know what you're thinking. You were thinking I went to 8-bit, but I didn't. I only went up to 64, which gives me, what's twice this number?
128.
128, right? So I have 128 options. This is actually, one of the options is 0, so this is actually 127. So these are our values between 100 and 0 and 127 because the MIDI system is based on a 7-bit number. Okay, and the reason they chose to go with 7-bit is because they said, look, there's 88 keys on the piano, and this gives us 127. If I went with 6-bit, the most I could come up with is a 65, right? And that's not enough keys for the piano. And if I went with an 8-bit, you're right, we have 255. And at the time, they thought, well, that seems unnecessary, so let's just go with 7-bit. Okay, so MIDI is in 7-bit notation. MIDI is 7-bit. It's in a 7-bit code because that allows for 88 keys on the piano. And so then they use that 0 to 127 range for the instrument names, for the duration, the time, the dynamics, and all the other messages in MIDI. All right? That's going to be important for you to understand as well. Okay. I want to go back to this sound instrument idea. So we said that pitch is one of the kinds of messages that are sent, and another kind of message is which instrument it's going to be. This is a curious little idiosyncrasy, but nowadays, or originally when synthesizers were being built, we called the name of the instrument. We called the name of the instrument a patch. Do you know why we called it a patch? The reason we called it a patch is because in the old synthesizers, they had cables to connect the plugs together. An old synthesizer was a funny thing. You maybe had a keyboard down here, and then you had a big board, and they had quarter-inch plugs, like you would use to plug in your guitar today. They had quarter-inch plugs, and they would connect them. Those, by the way, are called phone plugs because they use them as a telephone operator would use them. And this technology is kind of based on telephone technology. So I have all these holes for phone plugs, and then I would have cables. And coming into this hole would be an oscillator, and from this one would be a filter, and from this one over here would be a tone generator. And if I took a cable, I could connect those together to create the sound. Okay, so I am using a cable to patch this hole to this hole to this hole, and hence these were known as patch cables. And so when I created a flute sound, I would say it was the flute patch. Okay, so sounds used to be called patches, and on some synthesizers today, you will still see them referred to as patches. Okay, what do we want to call this? We want to call a flute an instrument, don't we? We want to call a horn an instrument. But it gets complicated because the real instrument here is the synthesizer or the tone module or the computer. That's really the instrument. And so the sounds of the instruments we want to define, they started to call them patches. Well, patches have been replaced. What have we done instead of doing this to make sounds generate in the computer?
Pre-recorded?
No, well, we do audio now, but this is back in MIDI. What did we do? And we still do it with the MIDI. We what did I say was built in that module is what?
Computer.
It's a computer. It's a computer. These are computer programs. So what I have is I have a flute program, right? It's really a computer program. And so now on synthesizers, you will see that it doesn't say patch, but most often it will say program. And this is called a program change in MIDI, okay? A program change. And so program refers to the instrument sound. You don't want to say instrument because you might have 5 tone modules, and we'd call those different instruments. But the sound of the flute or the sound of the trumpet or the sound of the guitar, those are all referred to as programs. Okay? Very good. Any other questions, or any questions that have come up as we've been discussing this? Okay, so that should clarify a few things about how MIDI works. Remember, it's important to understand that because MIDI was a series of messages, I could have the whole Beethoven's Fifth Symphony and all of the instruments and all of the timing and the sounds, and I could program the whole symphony into a computer. And because these are numerical messages, if I want to take the whole thing and take it from the key of C minor to the key of A minor, literally all I have to do is write one piece of information and it transposes the whole thing. If I want it to play twice as fast, all I have to do is write one piece of information and it plays twice as fast. Why? Because these messages are numerical, I can simply change the numbers and change the entire piece. This makes MIDI extremely valuable and useful for music making because it's very portable. If I have recorded the Boston Symphony playing Beethoven's Fifth Symphony in C minor, I can't write one piece of information and all of a sudden hear it in the key of A minor. I just can't do that with audio because that's not how it works. Also, I can separate in a MIDI message, I can separate the bass part from the violin part because they're all strings of messages from the flute part, and I cannot do that if I have a recording of the symphony as well. So let's think of an application for a music teacher, for example. I could put together a MIDI recording of a choir part in soprano, alto, tenor, bass. And if I want, I can mute the soprano, alto, and bass part and let the tenor practice with just the tenor part. And using the same file, I could mute the tenor part and have the tenor sing along with the other three parts playing, right? I can't do that if I have recordings of audio unless I make multiple recordings, right? So MIDI has an interesting flexible ability because of its numerical nature. Having said that, it's real limited in terms of the way it sounds because it doesn't sound like real recorded audio. Okay. The last thing
how MIDI smart music is to use through MIDI, right?
It does. It does a combination. Smart music does.
Okay.
I'm going to turn off my whiteboard, and I'm going to share my screen. Are you seeing my screen now, DJ?
Yes, sir. I see it.
Excellent. Okay. So I'm going to open up Safari. Bring Nick around, and I want to show you online something that you're going to need for your MIDI project. Now you've got your test your quiz 3 this week to worry about, but your MIDI projects are coming up, and someone actually emailed me and said, "Hey, I want to start early. Can you tell me a little more about this?" So these MIDI files, I'm going to go free MIDI file Beethoven. Oh, that's no fun. Let's do Don't Stop.
Dr. Phillips.
Yes.
If we have our own MIDI, like I have my own MIDI controller, could I do the project on like FL?
Absolutely.
Okay.
Yep, you don't have to use GarageBand. For this whole course, you can do the projects in FL Studio if that's what you've got, or in other programs as well. Yeah, it's more about the concept than it is about the specific interface you use.
Okay, thank you. That's all I was asking.
Sure. So here on Google, I found MIDIWorld.com, a whole compilation of Journey songs. Let's see. Here's "Don't Stop Believing." See, for 30 years, well, for 20 years, people couldn't really deal with digital audio, and in their spare time, they made lots and lots of MIDI files that are all still hanging out on the web. Here's "Don't Stop Believing." If I click on download, boom. Are you seeing that on my screen there, DJ? It just popped up here. And now, I wish it hadn't done that. So my computer is set to open up Sibelius, which is a notation program by default when it opens a MIDI program. I didn't want it to do that, but it's doing that.
That makes sense. I think are the computers in the tech lab the same way?
Yeah, so some of the computers in the tech lab will do the same thing, and that causes people to get confused. And I'm going to do a demonstration video that I'll put on the channel that will walk through the steps here and tell you what to do when that happens. But what I wanted to show you, let's quit Sibelius for now, is that here's this MIDI file, and if I play it, I don't know how it'll sound through the recording, but if I preview it, it'll just open with a QuickTime player. You're looking for .mid, that's the MIDI file identifier there, and let's just open it with QuickTime player. What did it do?
So I couldn't open it.
Oh, come on, play. Open with business. I didn't like it. Usually what will happen is if you just click on that, it will automatically default to QuickTime, and it will play the song. For your project, what you're going to do is you're going to open up GarageBand. I'll just go ahead and do this step real quickly. I'm going to do a new project in GarageBand. You'll notice that my GarageBand is different than the one in the lab. I'm going to do a new project. I'm going to create it's going to ask me to create some kind of track, so I'll put one track in there. Now watch this excitement. Are you ready? Here we go. I'm going to take my MIDI file. I'm going to drag that puppy right into GarageBand. I'm going to set it at the beginning of the piece. Ta-da!
Whoa.
And all of a sudden, there are all the tracks in this song. Whoops, hold on. Are you still seeing my screen, DJ?
Yes, sir. I'm seeing everything.
Nice. Look at this. Here's all the information.
Wow.
So if I push play,
Okay.
does that sound like garbage on your end, DJ?
No, that sounds pretty good.
You can actually hear it. Okay, I don't know because it's just going out of my speakers right back into my microphone and sending it online. But check that out, huh? So here's the information.
Yeah.
And what we have in a MIDI file, if I double click on this is the information that says play this note at this time for this long and make it sound like a bass in this case or a piano on another track. So there's all the information that I need to tell the computer. And what's happening is GarageBand is becoming the synthesizer, and it's picking all the sounds, and sometimes it guesses correctly, and sometimes it guesses incorrectly. So what we have here, look at this series of tracks right here. These are drum tracks. You can tell by the rhythmic nature how repetitive they are. But unfortunately, it's decided to play them as a piano track. Are you still seeing my screen, DJ?
Yes, sir.
Great. Okay. So guess what I'm going to do? I'm going to take a track here, and I'm going to say, I want you to be something besides a piano. I would like you to be a drum kit. Let's have you be. We're just going to pick a drum kit, and I'm going to pick this one, and I'm going to also make it a drum kit. And again, on the computers in the lab, your interface will be different. And if you're using FL Studio or something else, your interface will be different. But this is going to get us much closer. Let's see what happens if I put drum kits for all these sounds. And this is what you do in your MIDI project. Your job is to download a piece of MIDI music, and then oh, sounds like I missed one. Oh, I missed this top one here. Let me try that again. And you're going to change the instruments to either make it sound more realistic or, oh, there we go. Now we got our drums back.
call it that.
So kind of cool, right?
Yeah.
And notice that just with one switch, in this case, I said you can just rewrite the message. So in this case, I just said, well, I don't want it to be a piano. I want it to be a Liverpool drum set. And all of a sudden, it changes to sounding like a drum set instead of a piano. So it's that easy. And that's what you're going to do with the MIDI project. And this is just a great illustration of how MIDI works. You see that it sends messages into the computer. Now, the fascinating thing about this, especially with computers the size they are today, well, let's see. I'm going to look one more time at this piece. This piece, if I look in terms of time, I've got about 4 minutes of music here. Okay, so 4 minutes of music in this MIDI file, and this MIDI file, if I get info, is 37 kilobytes. That is a tiny file. That is a tiny file. If I were to take and make 4 minutes of music at 44,100, and I were to export that as an audio file and see the size of it, it might be, instead of 37 kilobytes, it might be 37 megabytes. Now, 37 megabytes doesn't seem very big to those of you who have a 500 gigabyte or a 2 terabyte hard drive, right? But in 1981, 37 kilobytes, a big, good computer could deal with. 37 megabytes, nobody could deal with. Okay, and so it's that illustrates why we were in a position in 1981 to make the sounds and find a protocol that would be so condensed and so efficient. Even though today we can do a lot more things because computers are faster. Fascinating that 25 years later, it's still as useful and used as it was in 1981, even though we have far superior technology with audio. One last thing I want to point out is that there is a software program. I've got it here on my desktop called Reason. I don't know if I can get it to open right now. Oh yeah, here, I'll open it in demo mode. And the way Reason works, and DJ, you've probably heard of Reason, it works similar to GarageBand, except what I do is I put in MIDI messages, and what it does is instead of using a software synthesizer like GarageBand is using, it will actually use pre-recorded audio of instruments. So, hey, should we try it?
Yeah.
Let's import a MIDI file and see what happens. From my desktop, we're going to find Journeys Don't Stop Believin'. Open. Now, we're going far above and beyond, and most regular students in the class have already tuned out of our session on the YouTube channel. But if you're with us, now you're getting the bonus material. Here we go. So look, down here, I've got all of that MIDI information, right? I've got all the MIDI information that we had in GarageBand. There's all of our instruments. There's all of our music. But now, instead of using software synthesizers to create the sound, it's actually using samplers. I'm not sure what it's going to sound like, but let's find out. Oh. That, my friends, is a Steinway piano. So when it says Steinway piano in the MIDI file, you put it into Reason, it actually creates a sampler with a Steinway piano and plays notes of someone who recorded those notes on the Steinway. Let's see, I don't know if it coded the drums better than our MIDI file did. So let's go to here and see what it sounds like. You can hear them kind of softly, and I don't know, DJ, if you're getting it through there. But there's some string sounds and some other things that are programmed, and I could turn up the volume of those. We could hear them better. But the point is, Reason is a program that is taking advantage of our modern computer's ability to deal with digital audio and still relying on MIDI as the backbone for that to create really terrific sounding. I mean, we're here listening to this, and it sounds like a real recording of piano. What's amazing about that, of course, is that if I take the piano, I can change it to electric guitar, and all of a sudden that really great sounding piano part is now a really great sounding electric guitar part.
That's cool.
And
then samples.
And if it was
just a synthesize.
That's right. And if it was audio, we wouldn't be able to do that. I wouldn't be able to change. All right, we're going long, but what if we did that? Let's see. I wonder if I can change this to guitar. acoustic steel guitar. Now let's do a clean electric guitar. Let's see what happens.
That's pretty cool.
Now, if I'd recorded a piano player playing that, there's no way I could all of a sudden go into my software and say, oh, hey, guess what? You're no longer a piano player, you're an electric guitar player, and change it, right? But because MIDI is the background and it's dealing with audio samples, it just replaces the samples of the piano player with samples of the guitar player, and we get actual guitar. But we can change it just like that. Now, I personally enjoy music from Eastern Kentucky. So here's a little dulcimer action. Just like that. So there you go. What turns out to look like extremely stuffy and boring technical information actually becomes rather useful in the real world of music technology. So have you guys got any questions?
No, sir, not at all.
So thanks for hanging out with me on this. I'm going to post this recording to the YouTube channel, and we'll send it along. DJ, thanks for joining us online, and